Did you know that you can convert your 1D array to 2D array by using the dot reshape function and then specifying how many rows that you want and how many columns? So I have this array and I want to convert it to a 2D array. So if I run this code, that you can see the elements 1, 2, 3, and 4, 5, 6 become 2 rows. And that's how they appear in the output. So the first 3 elements get put into the first row and the next 3 elements get put into the second row. This is how you convert a 1D array to 2D array in Python. In Python, you can make a copy of an array or create a view. If you make a copy of an array, then it will actually create a physical copy in memory. A view will basically refer back to the original array and you can do manipulation of the view. So here, if I just demonstrate that to you, you can see that I created a copy of the array and a view of the array. So they will have the same value. But then as soon as I modify one value element to 40, you can see the behavior starts to change. So I'm modifying it on the copy. So only the copy is affected and the original array stands as it is. And you can see they both have 10, while here we've got 40 in the copy array. But if you modify the view as shown here and you change the first element there, then it will affect the original array and also the view, but not the copy array that we made earlier. Now there is a way to check if you're using a copy array or you're referring to the view. By checking the .base property of an array, it will return to you either none. So as you can see here, if you have this, you get none, and that means that this is a copy. It doesn't have base data, whereas the view version of it will actually have the base. There is an alternative syntax to creating a copy of an array. And why would you do it? If we have a look at this code here, you can use this syntax and this will always generate a view to the data. So this will not create a copy. Now, if you want to create a copy, then what you have to do, okay, select that and then do copy. So why would you do a view versus a copy? A view is much faster, it's much more efficient, and a copy is actually going to take up memory space and processing time. So here, let's imagine you had a large image, and what you want to do is you want to change the brightness of a specific area of that image. So you specify in the array that you want to modify the brightness of that region. Then you can add the value 50 to it, and what it will do is modify that in the original image over here. And then when you print the image, that specific region will now have the new value. So those are really good and handy when you want to concentrate on a bit of the array and modify it. You can do the same thing for other things, such as like stock prices. If you're trying to work out the rolling window of the last 3 days, then again, by creating a view, not a copy of that data, you're able to modify the original array. And then the original array, when you print it, it will have the updated rolling window in it. So when you have a large array, always try and use a view unless you need to create copies. So just remember the syntax. You can use .copy or .view, or by simply referring to the array like this, it will actually create a view. So that's an important distinction. By default, this sort of a syntax here will create a view, not a copy. If you want to copy, remember to do .copy. Somebody asked me an interesting question on this video to do with NumPy arrays, copy versus view. They said, then what's the point of a view if you're just editing the original? And if you watch my video, yes, that's what's happening. The reason you would do that is to focus on a specific part of the array. So let's imagine you had a large image and you just wanted to modify one small part of that image. Rather than make a copy of the array and make the changes, you just wanted to increase the brightness of the image at a certain point. Then you can just focus array on that. You could create a view of it and run through your algorithms to increase the brightness, the contrast, and so on. So what's the point of that? Just think of it as like a mirror. So here, this person is looking into the mirror and they're only seeing their face. They can change something on the face. So, to get rid of this acne, they can put something on and they can see it live what their face appears as though. So they're not putting the acne cream all over their body. They are just focusing on their face and they're seeing, and just as you would do with brushing your teeth, you just look in the mirror and see yourself in the mirror. You're not taking a picture of yourself in the current state, which is a physical copy. You'd have to make an effort to store that picture, and then you can't change that original picture. So even if you put something on your face or you do something, you shave, whatever, that's now frozen in time. While with a mirror, you're looking directly and focusing just on your face. So that's an important distinction between a copy and a view. A view is just to enable you to focus on a specific bit of the array, and then you can manipulate that array segment that you have selected through the view, and it will also change the original. Just as you would, you look through the mirror, you shave your face, view then would actually, you change the original person. You haven't changed a copy, you have changed the real person that is you looking in the mirror in the view. I hope this answers the question that I had on here, which is, then what's the point of a view if you're just editing the original? In Python, the where clause can be used to not only find the indices of where the condition is met that you define, it can also be used to replace values. So if I run this code, and as you can see here, I have the following elements in my array, and now I want anything that is greater than 25. This will actually return indices where that condition is true. So it won't return the elements, it will return the index position of those values. So as you can see here, I have the index positions here, where this is 25. So we have the element 0 and 2. That's why I've got this returned here, 2, 3, 4. So you can use the where clause to replace values. So here what we are saying is if the value is greater than 25, we want to keep the value. But if it is less than 25, then we want to replace it with a 0. So here, this time, it will actually return the new array elements. It won't return the indexes or the indices. It will return the new array. So this is one of the difference. The where clause here will act differently and return different data type, because here it's returning a tuple, whereas here it's actually returning an array of the elements. So here, as you can see, the elements here are replaced by that are less than 25 with zeros, while the rest of the elements are still shown here. In my previous video, I talked about replacing values in an array using the where function. We can also use the where function to actually manipulate data between two arrays. So here I have this array and here another array. And what I want to do is, this is the condition that I want to apply. So if anything that is greater than 20, then I want to keep those values. So that would be 25 and 30. But if any values that are less than 20, I want to replace them with the values from this array. So this concept applies. You can actually use scalar values, so you don't have to use array. So here you can actually say you want to keep values that are greater than 25. If not, then replace them with zeros. So that would mean, for example, here 10 would be replaced by 0, then this would be replaced by 0, but these values would be kept. So if I run this code, and as you can see with the scalar replacement, you get these first two values replaced by 0. So here we're not using an array, but you can actually switch array elements. So here what we're doing is we are replacing the values that are less than 20. So here 10, 15, and 20, because it's greater than 20, not equal to 20. So here you can see 100, 150, 200, and then 25, 30. It essentially merges the two arrays together by using the where function and a condition you apply. And then, as you can see here, this is the output that we get. So remember to use the where function to actually filter your arrays and replace the values within the array. So essentially either replace or merge arrays. So the syntax for this is array 1, which is the first one we want. So this is the one where we want to keep the values that are greater than 20, or this would be these values, and then array 2 is the one where we pick the values if there are values that are less than 20, so which is this one. So this is the syntax for the where function. Or you specify a condition and then you specify how you want those values for replacing. You keep these values, so this is the values to keep the elements from, and this is to replace a value. If you use the where function in Numpy using this condition, a single condition that just retrieves the elements from an array, you need to understand that it returns actually indices. So it doesn't return the elements as you would expect. So it doesn't return 30, 40, 50. Instead, it returns the position. What I mean by that is, if I run this, and you can see if I get the values. The reason I get the values here is because I have this second array that I'm assigning, and I'm using the first array here, and I'm using the indices retrieved using the where function, and those indices are then in turn used to retrieve the values. So here, this is what it would look like. The reason this works is because it returns a list of indices which are greater than 25, and those would be in the position 2, 3, 4. So you can see this is position 0, 1, 2, 3, 4, and those indices would be returned. So that's what this indices, the where function, actually returns. And then you can do your output like this. If you don't want to access the indices like this and do it in 2 steps, you can simplify the process by not using the where function. Instead, you can actually use this syntax, which will mean that it will give you the values rather than the indices. So this is a bit of a shorthand. You put the array name in, and then you say you want anything that is greater than 25, and then you will get the values printed 30, 40, 50. So this is a shorthand of, rather than trying to access the indices, and then from the indices try to access the elements in here. So just remember, the where function actually returns indices rather than the actual element value. So I made this video on applying universal functions in Numpy array, and somebody made a comment to say, actually, you can use one-liner list comprehensions. So let's have a look at this comment and analyze it. So if I go back here, and this is the comment, and I've tried to copy the syntax that they showed here. And as you can see here, this is the alternative universal function syntax that I use. So what's the difference between two? If I run this code, then as you can see, same output for both. But there is one major difference. In the list comprehension variable type, we get a list type. But for the universal function syntax, we get an array. Actually, it's a Numpy array. So the universal syntax actually has quite a few benefits, which is it performs a vector operation. And what I mean by vector operations is it can process the array elements in parallel. So behind the scenes, it uses some C language library that will actually process the elements in parallel, while list comprehension will use a loop to go through the process. And so the Numpy array is actually stored in one contiguous memory block. So that means, of course, when it's doing parallel operation, it is much faster because they're next to each other. So it's faster to apply, operations on that, such as square root. faster. So there's no need to explicitly declare a loop as such. You basically use this syntax and it is faster, much more memory efficient, and will basically do the same job as above. But in this instance, universal function syntax here is much better, and it will give you much better results in terms of processing speed and memory use. And you will get an NumPy array at the other end, so you can further do any manipulation without converting between data types. So in my previous video, I discussed that vector operations are much faster in NumPy than using a loop. So this would be a non-vectorized operation. So as you can see here, that I am using a loop here, while here I'm using a vector NumPy operation. So if we were to time these, what do you think the difference between this simple code in terms of speed would be? I think you would be quite surprised by this, and this is sort of our data set, and how long will it take for this array to be multiplied by 2 versus this one multiplying each element by 2 and seeing how long it takes. And here I just go a bit of code to work the percentages, and then we'll get the percentage faster. So if I run this, and here this is the vectorized time, it took 0 seconds, and here we have the loop time, which is that. So the percentage difference is vectorized operation is 100% faster than the non-vectorized operation. So they're basically a loop. So loops are always slower. That's something important to understand in generally in coding, but in Python, when working with an array, the operation is much better if you can do it in a vectorized way rather than using a loop. The NumPy library behind the scenes uses C language to make this work in parallel, and that's basically what vectorization does. And if I run this again, and let's see if we get any different outcome, again 100% faster. And if I keep running it, and as you can see here, this time the vectorized operation took 0.001 of a second, and it is 97% faster versus the loop time of 0.04. So I hope that you found this video useful, and why there is a case for using vectorized operations as much as possible in your code and avoiding loops. Of course, loops have their place and you should use them. So I'm not against loops, but you should at least be aware of the differences. I hope you found this video. If you have, please like and subscribe. In my previous video, I talked about universal functions in Python. These are the universal functions. But how do you know you're working with a universal function? Universal functions can be worked out using the type of the function. And what you will get is, you can see that the type is NumPy ufunc. This indicates this is a universal function, and as you can see, it's the same for the others. Universal functions use broadcasting. As you can see here, we're adding 10 to each element within the array. There are no loops involved here, so you can tell that this is using broadcasting. While here, you can see that we're using a loop. Loop is not a vectorized operation, so it is much slower to run. So this does not use broadcasting. So just remember, universal functions all use vectorized operations, which are much faster because they work in parallel, while loops do not. But just remember, you can find out a type of a function, and if it returns ufunc, this means you're working with universal function. And in turn, by default, all universal functions have vectorized operations. So that means it is using broadcasting. And the operation here, such as plus, minus, multiply, these all use broadcasting. So you can consider them as similar to a universal function. Did you know this about Visual Studio Code, which is that it highlights issues with your file? So here, as you can see, I have made a syntax error. And if I fix the syntax error, something will happen with the dial. So here, you can see that the color of the file, the reason it's red is because I've got a syntax error here. And I've got here, which is in yellow. And the reason it's in yellow is because I potentially have an issue here. Here, you can see that I am using undefined variable. So here, undefined variable is this I haven't imported in by plan. So a difference between a syntax error is this code won't run. Here's the potential issue that I'm using an undefined variable. And the interesting thing is Visual Studio Code will highlight the issues with your files here. So you can see all the ones in white are there are no issues, and the one in red and yellow, there's potentially an issue. So here I can fix this error. So as you can see, I've got an error here, which is a syntax error. So if I can get rid of that, and you'll see the color of the file changes. And if you look at this, the color has changed. And same here, this is without saving it. If I go here, just comment this out like this with type ignore, then you can see the error has gone away and the color has changed back to white. So here you can see it's gone back to white as well. Oh yes, Visual Studio Code uses color to identify issues with your files, especially if you have a lot of files in your project.